Good day, class. This is the last part of vectors. We want to look at the resultant of more than two forces. And for you to understand this topic better, you must have watched the first 3 videos I dropped. Now, the resultant of more than two forces or vectors. So I'll just go straight with an example to an example. So this is vertical, and this is horizontal. So this is the x-axis, positive x-axis. This is the y-axis. You know, this is negative x because here is origin, right? Here is the origin. Okay. So if you have a force in this direction, let me assume this 10 Newton at an angle, let me say 40 degree to the horizontal. Then you have another force in this direction. Let me assume this to be 60 degree and this 15 Newton. Okay, there's another force here. Let me take this one to be 5 Newton. Then at an angle here, let me say angle 50 degree. Yeah. This 1, 2, 3. And let me put another force here. Let me put another force here. Let me call this one 9 Newton. And then lastly, another one here. Let me call this one 20 degree. And then this force 13 Newton. All right. So this is all we have. Now, what if you have to find the resultant of these forces? Resultant of these forces 1, 2, 3, 4, 5. We have 5 forces here acting on a particle here. So there's a particle at the origin here. So we have 5 different forces dragging this particle. So in which direction do you think the particle will go? So the resultant is of the 5 forces will now be that singular force. That singular force that is going to replace the 5 forces, both in magnitude and what? And direction. Now, the first thing we are going to do is to pick each force, each of the forces, pick them, resolve them into horizontal and what? And vertical components. Then add all the horizontal components together. Also add all the vertical components together before you now apply the law of parallelogram of forces. So for convenience, I'm going to use a table. And this is how the table will be. Force in Newton. Force in Newton. Then this is going to be angle of inclination to the horizontal. Angle of inclination to the horizontal. So please don't forget, we are using angle of inclination to the horizontal and not to the vertical. Then this is going to be horizontal component. You will find the horizontal component of each force. Then lastly, we have vertical component. You also find the vertical component of each force. Then draw your line. Okay, so let's pick the force from here. 10 what? 10 Newton. You don't need to put Newton here. I've already put it here. Then angle of inclination. Angle of inclination to the horizontal. Angle of inclination to the horizontal. So what's the angle of inclination of this 10 Newton to the horizontal? Now, this is the origin where this force is coming from. And then since the force is going in this direction, this is what? Horizontal. So what's the angle between the force and the what? Horizontal. That's 40 degree. Now, this question can be a bit subtle because of science. Because of what? Science. You know, yes, positive what? Y. That's from here up is positive Y. Anything going upward is positive Y. Here is negative what? Negative Y, right? Then here is what? Positive X. While here from the origin here to this place is what? Negative X, okay? So any force that is in this direction is positive X and positive Y. While any force in this direction, positive Y because it's going up and what? Negative X. Any force that is in this direction, negative X, negative what? Y. While any force in this direction, positive X and negative what? Y because it's going down, okay? So this force now for the horizontal, is it positive or negative? So the force is moving to the right hand side. Yes, positive, positive, right? So this is going to be positive F cos what? Cos theta, because we have said that the horizontal component of any force that is inclined at an angle theta to the horizontal is that force times the cos of that angle of inclination. So that's going to be 10 cos what? 40. And 10 cos 40 will give us 7.6604. Then what about the vertical? Is it positive or negative? Please always think about your sign first. So I told you, yes, positive and what? Positive X and positive Y, right? So this is going to be 10 sine 40 degree, right? So 10 sine 40, that's 6.4279 approximately Newton. Okay, so we are done with 10 Newton. Please, your signs are very important. So it can either be positive or negative. Now we move to the next force, 15 Newton. So move to the angle. What is the angle? So is this angle is the angle of inclination that or to the horizontal you are going to use for both horizontal and what? Vertical component. You can see that this 40 is what we use here and here. Okay. So what's the angle of inclination of this? Now let me play a trick with you. Let me play a trick with you. Let me call here 50 degree. Okay. Or let me play a trick on you. So the angle of inclination to the horizontal is what? 60 degree. This 60 degree. Now the horizontal component, is this force going to have positive or negative horizontal component? What did I say here? Something is moving this way. That's what? Negative horizontal. So your minus first. So that's going to be minus 15 cos what? 60 degree. And that's minus 7.5 Newton. Then what of vertical? Is it going to be positive or negative vertical? So it's going up, isn't it? It's going up. So vertically upward. So that's going to be positive. So that's 15 sine 60 degree, which will be 12.9904 Newton. So we are done with 15 degree. We move to the next force. That's what? 5 Newton. This 5. So what is the angle of inclination of this 5 Newton to the horizontal? Now, what's the angle? I know some of you will say 50 degree. The angle of inclination we have here is to the vertical, not to the horizontal. Where's the horizontal? The horizontal is this way. So we need the angle between this force and this line. But we are given the angle between the force and what? And the vertical. So if here is 50, what is here? What is this angle here going to be? This is the angle we are looking for. You know, from here down here is what? 90 degree. That's perpendicular. So 90 minus 50, that's what? 40 degrees. So this angle is 40 degree. Now we have to decide, do we have positive or negative horizontal? Now this force is going towards the left. So anything in this direction, you can see now, is negative what? X. So that's going to be minus 5 cos 40. 5 cos 40. That's minus 3.83022 Newton. Or let me use 4 decimal place, please. Then for vertical, is it going to be positive or negative? Vertical component. This force is going vertically downward. So this is something going this way is vertically downward. So that's going to be what? Negative. Anything going down is negative vertical. So that's minus 5 sine what? So vertical component is always sine, horizontal is always what? Cos. So this is going to be minus 5 sine 60 minus 4.3301 Newton. Then we move to 9 Newton. We are done with 5. 9 Newton. This 9. Now, class, what's the angle of inclination of this 9 Newton to the horizontal? Where's the horizontal? So you can either pick here or what? Or here. So what's the angle between this 9 Newton and here? This horizontal, this vertical. That angle is what? 90 degree. Or you say from here to what? To here. That's still what? 90 degree. Are you following? So what's now going to be the horizontal component? That's 9. Now, is it positive or negative? So it's neither going positive nor what? Or negative. 9 cos 90 degree. So just leave it as positive there. That's equal to what? 0. Cos 90 is 0. So it means this force doesn't have any horizontal component. And I believe you can relate with that. Since it's moving directly vertically downward, it means it's not going to have any horizontal component. It will not have any effect in the horizontal direction, either to the right or to the what? To the left. No effect horizontally. So the 9 Newton is its effect is totally downward, which is vertical. Okay. Then the vertical component is going to be, now since it's going down, it's going to be what? Negative. That's minus 9 sine 90 degree, which is minus 9 Newton. Okay. The last one, which is 13 Newton. 13 Newton. So what's the angle of inclination of 13? This 13 to the horizontal. The angle between this and horizontal is what? 20 degree. So the horizontal component, is it positive or negative? That's going to be positive. That's 13 cos 20 degree. And if you find that in a calculator, 13 cos 20, that's 12.216 Newton. Then for vertical, is it going up or down? So it's down, right? Negative vertical, that's minus 13 sine 20 degree. So 13 sine 20. That's minus 4.446 Newton. Okay, so we are done with that. So we are going to find the sum of all the horizontal components and the vertical component. So sum of fx, then sum of fy, where fx is the horizontal component. So pick your calculator, the way they appear, the plus and the minus. So press it out in your calculator. 7.6604 minus 7.5 minus 3.8 302 plus 0, then plus 12.216. So we have positive, that's going to be 8.546 Newton. Maybe I should try again. 7.6604 minus 7.5 minus 3.8 3024 plus 12.216. So that's correct. Then sum of my vertical component, that's 6.4279 plus 12.9904 minus 4.3301 minus 9 minus 4.446. That's 1.6418 Newton. So that's the effective value in the vertical direction. Now this one is also plus. So both of them are plus. Now I'm going to draw the final diagram. So all these forces now, they've been resolved into horizontal and vertical components. Now see the final diagram I have. My final diagram is going to be derived from the summations that I have there. From the summations I have there. Now both of them are positive, right? Positive x and positive y. Now see what I'm going to do. Meaning this is where the force, this is the origin, this is the particle. The particle is there now. So if the particle is here, it means all the horizontal now, they are dragging in the positive direction. So you are going to draw something like this. Positive horizontal axis. So we have something like this. This 8.546 Newton. So you don't need to put the plus. This plus is to tell you that you are going to the right hand side. Then this other one, for the vertical, we also have plus. So if it is plus, we are going out upward from the origin here. So this is it now. This is 1.6418 Newton. So all those forces now, this is what we have for them. They've been resolved into these two forces. So that we now look for the resultant using the law of parallelogram of forces. So where will the resultant be? The resultant now, if yes, the origin, the resultant will now pass in between them. So this is the resultant in this direction now. So which is FR. All right. Now, please, it's not every time your diagram will look like this. What if both of them are negative? If both of them are negative, you are going to have, if yes, origin. For negative, you draw left hand side for x. This summation fx. Then from the origin again, how do you draw? You draw downward. This summation what? Fy. Then where will be your resultant? From here. If x is positive and y is negative, you have something like this. Summation what? Fx. Y is negative, right? Downward. Summation what? Fy. Then your resultant. And so on and so forth. Okay? So if I apply the law of parallelogram of forces now, complete this diagram to form your parallelogram again. So yes, Fy, isn't it? Upward. Then draw this. Yes, what? Fx, which is to the right hand side, 8.546 Newton. This one is 1.6418 Newton. Now, my fx and fy, they are at what? 90 degrees to each other. So 180 minus 90, definitely here is going to be what? 90. Here is what? 90. So that we now have a right-angled triangle. And you can now use any of these two triangles. So let me bring the triangle up. Let me bring it out. So I have something like this. I'm using the triangle up. You can use any of the two triangles. Okay? So we have this origin, this my resultant FR, this FX, 8.546 Newton, this FY, 1.6418 Newton. Now, if you like, use the law of parallelogram of forces. Use cosine rule. If you use cosine rule, you will still arrive at Pythagoras theorem. This is the angle. This is the direction, because you must find both magnitude and what? And direction. This is the magnitude, while alpha is the direction, the angle between FR and the what? And the vertical. But if you are using the other triangle, you are going to use here as the direction, beta. Use angle beta, the angle between the resultant and the what? And the horizontal. Okay, so since this one is giving us a right angle triangle, just use Pythagoras theorem. FR square equals to Fs square plus what? Fy square, which is now FR square equals to 1.6418 square plus what? 8.5546 square. So this 2.6955. Here's the hypotenuse, right? Okay. 556 plus 8.546 square. That's 73.0341. We have 75.690. That's FR square, so that FR will be square root of 75.690, and that's 8.7 Newton on the dot. So this is just the magnitude of the resultant force. Then what of the direction? If you like, use tan. If you like, you can also use this is adjacent and this is what? Hypotenuse. So you can use cos. Okay. So, but textbooks like using tan. So we can say tan alpha. Tan alpha equals opposite. This opposite, this what? Adjacent. That's F what? Fx. Fx is the opposite to alpha over what? Over alpha. But if you are using this, it's going to be Fy over what? If you are using this triangle here, it's going to be Fy over Fx. So don't cram. It depends on which triangle you are using. So this is going to be 8.546 over 1.6418. 8.546 divided by 1.6418. That's 5.2053. And alpha is tan inverse of 5.2053. That's what? Tan inverse of answer 79. So therefore, alpha equals 79.1 degree. Now, you can draw your conclusion and say, therefore, are you following? Therefore, the resultant equals, what's the resultant? The magnitude is 8.7 Newton. At what angle? 79.1 degree to the what? To the horizontal. So, no, to the vertical. To the vertical. But it's better you use compass bearing. No, here is vertical, right? Here is alpha. If I use compass bearing, if I complete this horizontal, this is what? Vertical, right? So yes, north, cardinal point, yes, east, west, and what? And south. So instead of same to the vertical, this is going to be north, what? East. If you know your compass bearing, this this angle is in between the north and what? And east. So north what? East. So that's the resultant. So that's all for vector. Thanks for watching. Like, comment, subscribe, and share. Thank you.